Hello, everyone. This is Dr. Jackson, as usual, and this is the lecture for Chapter 6, the Introduction to Inferential Statistics. We'll be looking at sampling and the sampling distribution for this particular chapter. So just here's some of the learning objectives while I talk a little bit about the chapter. Previously, in the first 5 chapters of the book, we talked more about descriptive statistics. We talked about just the numbers that are presented to us, things like the mean, standard deviation, so on and so forth, that just tell us things about the population. Now what we're moving into is looking at stuff related to samples and how that information can tell us something about the population as a whole. So we're starting to move more into where we start to make inferences or conclusions about a population based on something from a sample. But before we dive into all of that, you need to understand some terminology, some of the different things in terms of how it is that we're able to do this. So this is what Chapter 6 will talk about. This is what we'll talk about in Chapter 6. You'll see different types of sampling methods, and I'll also talk about sampling distributions themselves. All right, so this is just, again, the chapter outline. I'll talk about all of these different things and then close it out with some of the symbols and terminology that you need to make sure you pay close attention to and that you keep handy if you have something where maybe you write notes. And I know some folks like to have a spot where they have all the formulas. It may be that you want to do that for some of the symbols and terminology, because through chapters 1 through 5, we were looking at things, even though some of the stuff would say sample, we talked about and calculated things in terms of population. Now it's going to start to, you'll start to see why I made it a point to demonstrate or show you the difference between samples and populations in some of those formulas. Okay, so this is just continuing, I think, a little bit of what was on the previous slide. So to get into it, getting started and to talk about the things that are in this chapter. So here's some of the basic terminology. There are going to be some four different terms right at the beginning. So population, sample, statistic, and a parameter. But the first term, population, one of the key things that's problematic for social scientists, people like myself who look at issues related to, society and different things like that, social scientists, and the research that we do, is that the appropriate populations for some of the tests and the research that we do, some of those populations are really, really large. And it's not realistic for us to think that we'll collect data from every single person in our target population. For instance, I might want to know information about crime in Harris County. Well, Harris County has a population of well over 4 million people. I think the last time when I updated some of my information, I had that it's a population of about 4.3 million people. I think it might be 4.4 now. Whatever the number is, Harris County is an extremely large county, and it is growing, okay? It's the 3rd most populous county in the United States. It would be unrealistic and essentially impossible to collect data from every person in the county. This would be true even if I narrowed my target population down to juveniles, or even if I narrowed my target population down to a specific group, so females, minorities, African Americans, people from Hispanic or Latino descent. Regardless of if I narrowed that topic or my target area down, my target population, it would still be unrealistic for me to collect that data. So what we tend to do is we collect data from a sample. Okay, so that's our solution. To deal with this problem that we face with populations, we use inferential statistics. And that's what a lot of what we'll be talking about for the remainder of the semester deals with, inferential statistics. More specifically, we use a sample to better understand a population when we can't access the entire population. So again, in other words, when it isn't feasible to use the entire population, we use a sample of the population. Basically, we're able to learn about the characteristics of a population due to what we learn about the sample. And this again is what we refer to as inferential statistics. When working with samples and sampling, we should know and understand that there are two types of sampling. One is non-probability sampling. Sometimes this is called convenience sampling, okay? But typically for the purposes of this, the book that we're using for this class and for what we're talking about now, I'll stick with the term non-probability sampling. And what that means is these are samples that lack generalizability. And what generalizability means, that's when we're able to take that sample and generalize it to the population. So if I take a sample of students, if I take a sample of 500 students from PBAMU and I conduct some research using that sample, I can generalize back to the population of PBAMU students. However, if I say, let's say for non-probability sampling, and what we typically use them for more often than not, we use them as convenience samples. An example of that would be if I, rather than randomly selecting 500 students from across the university, let's say I just go into the criminal justice undergraduate classes and I say to the students, hey, I need to conduct some research. Would you guys be willing to complete my survey? And I go to all of the CJ classes. That's a convenient sample. It's convenient for me to utilize PBAMU students within the criminal justice or justice studies department, okay? So yeah, then I wouldn't be able to take that sample and generalize my findings and make conclusions about those findings and say that those conclusions could be used for the entire population of PBAMU students. All right, probability sampling. This is the type of sampling that's more accurate. It's way more accurate than non-probability samples. And it's typically going to be representative of the population from which it's drawn. And most of the samples that we discussed will be probability samples. So basically, a probability sampling is where typically the sample is drawn randomly, and it's typically representative of the population that it comes from. Okay, so I've talked to you about population and I've talked to you about a sample. Now, I have been saying statistics this, statistics that, so on and so forth. Well, here's the thing. There's an actual meaning and there's an actual meaning to the word, okay? As you can see here on the screen, it indicates that statistics are mathematical characteristics of samples. The thing to remember, and I think one of the videos in your lessons does this, they make the connection between a sample is for a statistic, and both of those words start with an S. A parameter is basically describing, or it's a mathematical characteristic of a population. Parameter, population, both of those start with a P. If it helps you remember which one goes with which, just remember parameter, population, both of them are P. Statistics, sample, both of those are with an S, okay? There are differences between the two, okay? So again, a statistic and a parameter, they're similar in that they're both used to describe and discuss groups, but there are some differences between the two. For instance, statistics are used to describe the characteristics of a sample, whereas parameters are used to describe the characteristics of an entire population. When determining the difference between a statistic and a parameter, consider the following. Is the information about the whole population? Okay, if it's about the whole population, then it's a parameter. This can sometimes be the case when you have information about a small population. In this instance, we would still have a parameter. A lot of the examples that were used in chapters 1 through 5, sometimes they use the word sample, but they were really talking about populations, okay? But it's possible to have information about a small population. And again, if it's a population, then the information that you're finding is a parameter. So, and here's an example. United States senators. There are only 100 senators, and you can count how each one has voted. So if there's some piece of legislation, right now, at the time of me recording this, It's recent, it's shortly after the election, excuse me, shortly after the 2020 election. So a number of cabinet level people are being voted in or whatnot. And we can always look back in terms of the Senate and see who voted for what. Okay, there are a number of bills that are going through both the House and the Senate, and we can look and see what senators voted for what. Okay, but United States senators, that's a population. If that's what specifically what we're looking at, there are only 100 of them. That's a small population, and so whatever you do, if you're counting how each one is voted, that would be a parameter. Another example, 25% of 200 workers at a distribution plant have a college education. You have the information about who has the highest education completed. Your population is the 200 workers at a distribution plant. That 25%, that's your parameter, okay? If, however, I said a sample of 50 workers was taken from 200 workers at a distribution plant, and 25% of the 50 have a college education, then that 50, that's your sample, because that's 50 out of 200. And then that 25%, where it says 25% of your sample, that would be your statistic, okay? Now, sometimes it's going to be obvious that the information you're given is about a large population, that you're dealing with something that's being taken from a large population. And those numbers, so like if someone says a sample are 500 people, 500 Harris County residents report blah, 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 blah. Or here's another example. 40% of Harris County, Texas residents report being the victim of a crime. Since Harris County, Texas has well over 4 million people, and it's the third most populous county in the United States, it's not possible to collect data from each resident. Therefore, the researchers most likely have taken a sample of the population, and we can infer that 40% is a statistic, okay? So again, key things to remember. Statistics deal with samples. Those are characteristics of samples. Parameters are characteristics of populations. Statistics are used to estimate parameters. We typically learn something about a population, or we can learn something, in terms of the parameter by using or looking at statistics, okay? All right, so to talk a little bit more about samples, while it's one thing to say that we use samples to describe a population, we want the sample to be representative of the population it's drawn from. So this is just to kind of give you an idea of things that a sample should have and what it should look like. But one of the key things is it needs to be representative of the population from which it was drawn. You don't want a sample where, let's say you're pulling a sample of PBAMU students. And we know we have a wide variety of students in terms of socioeconomic backgrounds. Socioeconomic backgrounds, people who live on campus versus off campus, classification level, the types of majors. We have a bunch of different things that, a diverse population when it comes to those types of things. So if you remember my example a little while ago when I was talking about convenience or non-probability sampling, and I said that I just went to criminal justice classes, that sample would not be representative of PBAMU students, because if I'm pulling my sample just from criminal justice majors, then what about all the other majors on campus? So that sample wouldn't be representative, okay? A representative sample is going to have the same characteristics or similar characteristics as the population it was drawn from. Now, if a sample is to be useful and provide accurate information about the population it represents, the sample should contain the same or close to the same variation as the population. So essentially, the sample should look similar to the population it was drawn from. This is another example of representativeness. So for instance, if the population of a town is 55% female, and 45% male, the sample should consist of a similar percentage of males and females. Now, keep in mind that the more heterogeneous, and that would mean different, dissimilar, or diverse a population is, the more likely the sample may not fully represent or describe the population. So the inferences made about the population could be incorrect. Now, also, when we have a heterogeneous population, the sample does in fact need to be larger so that you have a better chance of making sure that sample is heterogeneous as well. Now, although social scientists want to make sure their samples are representative, there's no guarantee that samples will be fully representative of the population they represent. However, the equal probability of selection method, EPSEM, that's in bold on the screen. The EPSEM method it can help us reduce the likelihood of obtaining a unrepresentative sample. So note that this method is not a guarantee of representatives, and that the EPSEM and representativeness are not the same thing. Okay. The thing to keep in mind is the equal probability of selection method, EPSEM, is basically something that helps reduce the likelihood of getting a sample that's unrepresentative. It's a method, okay? It is not saying that it is not representativeness in and of itself. These are not the same thing. All right, so these are those terms you're going to want to familiarize yourself with. They'll be used throughout the remainder of this chapter and the textbook. You need to be able to know the difference between a population and a sample, parameter and a statistic, representativeness, and EPSEM. You need to know the difference between the two. Also, when it comes to population and sample, as we move forward and we start calculating things, especially in chapter 7, as we start calculating different things, you're going to need to be able to identify a population and sample within a problem. And because that's going to determine what formula you use in some instances. All right, what we have here are some of the sampling techniques for EPSEM, okay? So at this point, I'm actually going to stop the video because I want to talk about all of these at the same time. So I'll stop the recording at this point, and the next part of the recording, so part 2, will pick up here on this slide again, and then I will talk about each one of these different sampling techniques.